In this video, I will walk you through free response question number 4 from the 2009 AP Calculus exam. This problem is mostly about area and volume. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared as shown in the figure above. Part A, find the area of region R. You can find the area between two curves by integrating with respect to x if you integrate the top curve minus the bottom curve. When you integrate, you essentially add up all of the little vertical slices in order to form the area. Region R from left to right goes from 0 to 2. So in order to add up all of the little vertical slices between 0 and 2, the limits of integration will be 0 and 2. Let's take it term by term. Integrating the first term, I'm going to just bring down this x. I need to increase the exponent by 1, so I'm going to make that squared. And then I divide by the new exponent. 2 divided by 2 is 1, so I write nothing. Moving on to the next term, I see the x squared, but I'm going to increase the exponent by 1, making it x to the third power. Dividing by the new exponent gives me a 1/3 right here. Next, we apply the limits of integration from 0 to 2. This tells us to find the value at 2 minus the value at 0. So here is the value at 2, and it's easy to see that if I plug in 0 to both terms, I'm going to get 0. So here's the value at 0. Of course, 2 squared is 4, and 2 to the third power is 8, times 1/3 is going to be 8 over 3. If I make like denominators, this will be 12 over 3 minus 8 over 3, which is equal to 4 over 3. So 4 over 3 is the simplified answer to part A, but please understand that you can leave your answer in this yellow form for a free response question and still get full credit. And in many cases, you might want to leave it like this instead of simplifying to avoid the chance of making a careless mistake in the simplification process. Part B, the region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals sine of pi over 2x. Find the volume of the solid. When we talk about a solid that has region R as its base, I want you to picture a strange and skinny loaf of bread that is sitting right on region R. And we are looking down on the top of this loaf of bread from above. When we talk about cross sections perpendicular to the x-axis, I want you to imagine taking small slices of this loaf which are vertical. Normally, finding the volume of a solid sitting on an area is a three-step process. First, we find an expression for the base of a single slice, and then we use that to find an expression for the area of a single slice. And then we move on to find the volume by integrating the area. But for this particular problem, they were extra nice to us, and we don't have to do step 1 because they already gave us an expression for the area of a single slice. So we can skip straight to step 2 and write, okay, the area of a single slice will be the sine of pi over 2 times x. And in that case, the volume, which is always going to be the integral of the area, will just be the integral of sine pi over 2 x dx. By the way, what's really happening is when we integrate the area, we are adding up all of these vertical slices of bread. And when you add up all of the slices, you get the volume. So it's just a matter of what will the limits of integration be. Well, just like for part A, we see that region R from left to right goes from 0 to 2. So those will still be the limits of integration. I would usually integrate an expression like this using mental U substitution. but I am going to show you how to do it. Since you can't read my mind, I want to make sure we are all on the same page. But look, if I were to use u substitution, the u would be what is going on inside of the function. So u would be pi over 2x. And then we always need to know what u prime is. But u prime would just be pi over 2. Whenever u prime is just a constant, usually you can just do mental u substitution and understand that the only change that you have to make is that you will have to divide by that u prime, divide by the constant. And dividing by pi over 2 is the same thing as multiplying by 2 over pi. So if I just put the 2 over pi in the front, then I can just go on with my integration. The antiderivative of sine is negative cosine. So I'm going to go ahead and put the negative out in the front. And then here's my cosine of pi over 2x. Okay, so that was my mental u substitution. Maybe I'll go ahead and do the part where I apply the limits of integration from 0 to 2. And I'll pick up from here in a second. But now let me go back and show the mental u substitution. So I'm letting u equal pi over 2x, which means that u prime is going to equal pi over 2. So when you do your substitution, what you do is you write your integral, and then you say, okay, I now have the sine of u, but instead of dx, you write du divided by u prime, which is pi over 2. And again, dividing by pi over 2 is the same thing as multiplying by 2 over pi. So I can take this pi over 2 in the denominator and put it out in the front as 2 over pi. And then we would take the antiderivative, so we would have 2 over pi, and the antiderivative of sine is negative cosine, so I have my negative and my cosine. And then at this point we would substitute back in for u. So instead of u, we would put pi over 2x. Okay, and then we'd go on with the limits of integration, and we get to here. But all of this u substitution stuff, when the u prime is just a constant, you just know you're going to end up dividing by this. So just go ahead and divide out in the front and move on with the problem instead of wasting all that time. Okay, anyway, the limits of integration. So we have to find the value of 2 minus the value at 0. So I've got my negative 2 over pi, and I've got the cosine of pi over 2 times 2. So that's the value at 2. And now I need to do minus the value at 0. Okay, so I've got the cosine of pi over 2 times 0. But the 2's cancel out, so you have the cosine of pi, and pi over 2 times 0 is just 0, so cosine of 0. And then we know that the cosine of pi is negative 1, and the cosine of 0 is positive 1. So this makes negative 2 over pi times negative 2, which equals positive 4 over pi. Kabam! Part C. Another solid has the same base r. For this solid, the cross-sections perpendicular to the y-axis are squares. Write but do not evaluate an integral expression for the volume of the solid. So once again, when we talk about this solid, I want you to picture a long skinny loaf of bread sitting on top of region R. In this case, the difference is that the cross sections, the slices, are squares. Another difference is that on the previous problem, we were slicing vertically. Our cross sections were perpendicular to the x-axis. but for part C, we are slicing horizontally, which means that in the end, when we integrate and add up all of these slices to find the volume, we will be adding vertically. So we are going to have to integrate with respect to y on this problem. In the setup of the problem, we were given these two functions which form the boundary of area R. These functions are written with respect to x. Since we are going to be integrating with respect to y, we need to rewrite both of these as functions of y. In other words, we need to get x by itself. So for the first function, if I divide both sides by 2, then I get y over 2 is equal to x. So this is the version of the function that we will use for this problem. I think I'll write it over here. So the purple function is y over 2. Similarly, if I take the square root of both sides of the second equation, I get the square root of y is equal to x. So this is the version that I will use for this problem. And yes, normally when we take the square root of both sides, we do a plus or minus, but in the setup of the problem, we were told we are strictly dealing with the first quadrant. So we only need the positive version. So the red function is the square root of y. In order to find the volume of the solid, we are going to do the three-step process that I mentioned earlier. Step 1 is to find the length of the base of a single slice. So the length of this blue segment. Notice how it runs from left to right. So I can find the length of this segment by subtracting the right function minus the left function. So I can do the square root of y minus y over 2. So that's it for step 1. This is an expression for the length of a single slice. Step 2 is to find an expression for the area of a single slice. But in this case, we are told that the slices, the cross-sections, are squares. So if we have a square with base b, then the area is going to be b squared. That was a really simple formula to come up with on the fly, but some of the formulas take a lot of time to come up with, so I recommend that you memorize the following formulas for the area of a shape with base b. For a square, it's b squared, like we just saw. For a rectangle, you just sort of have to figure it out. So don't worry about memorizing the rectangle. But for an isosceles right triangle that's sort of on its side, like this, then the area will be 1/2 b squared. For an isosceles right triangle with hypotenuse as the base, then the formula for the area is 1/4 b squared. And then these are the other two formulas that are very common. If you have an equilateral triangle with base b, then the area is radical 3 over 4 b squared. And if you have a semicircle with base b, the area is pi over 8 b squared. So these come up all the time. You do not want to have to derive these formulas in the middle of a problem. So notice that all of these formulas involve b squared, not the rectangle. But the rest of them all involve b squared. So you just need to memorize the correct coefficient that goes in front of the b squared. So pause your screen, memorize these two formulas, and then pause your screen, write down and memorize these two formulas. Anyway, the area is b squared. Let's take our expression for the base and turn it into an expression for the area. If the area is the base squared, we can transform this into an expression for area by simply squaring what we have. The last step is to come up with an expression for the volume by integrating the area. So in this case, we will be integrating b squared. And remember, the slices are horizontal, so when we stack them up, we are adding vertical slices. So that's why we are integrating with respect to y. So let's take our expression for area and turn it into an expression for volume by integrating. So if we integrate the area expression that we have with respect to y, all we need are the limits of integration. And as we stack these slices vertically, the slices go from 0 up to 4. So these are the limits of integration. They said write but do not evaluate an integral expression for the volume of the solid, so this is the answer to part C.